Okay, we're going to talk about simplifying algebraic expressions. Go ahead and take a look at this diagram and copy down any notes that you feel are necessary. We're going to take a closer look at how you can use manipulatives, or these drawings, to make an equivalent algebraic expression. When you're ready to continue, go ahead and pause this. When you're ready to continue, go ahead and press play. So let's say you have 2x and 3 plus 3. So let's take a look at this. Alright, so right here we can write this as 2x plus 3. And what we're doing, according to the setup on the other page, is we're adding 3 x's, plus 1. Okay? So when you have this, you can group them. So let's see what happens when we group. Go back to my arrow. So now I can use the commutative property, and I can put all my x's together. And I can also group the 1's. So now what I have down here is I can add up all these x's, so that would be, let's see here, whoops, 1, 2, 3, 4, 5. So here is 5x plus, and if you count these up, there's 4. So this equivalent expression, or this expression, whoops, I just crossed it out, is the same as this up here. These are equivalent expressions. It's just a matter of using the properties to move them around, and that's why addition is so important. Alright, let's go ahead and go to the next one. Alright, so what I'd like you to do is model each expression with algebra tiles or a drawing. You don't necessarily have to do that if you understand this concept. But go ahead and write out the new expression by combining the like terms. When you're ready to begin, I'll go ahead and show you the answers. Okay, so here's what you should have come up with for A, B, C, and D. Alright, let's move on. So when we simplify, and you should already have some notes on this already, each part is called a term. And within that term, you have a coefficient and an unknown, or a variable. If you have a term that doesn't have an unknown or a variable, then it is called a constant, right here. Also, you have like terms. Like terms can contain the same variables or unknowns, and they can be grouped together. When you're done taking notes off of this, you can go ahead and continue on. So go ahead and let's check. Are 5x and 5y like terms, and explain. Go ahead and write down an explanation, and then when you're done, go ahead and continue, and you can see the answer. You should have answered no. They contain different variables or unknowns. Alright, so identifying parts of an expression. You want to be able to identify terms, like terms, coefficients, and constants. And the best way you can do that is to turn, which I've been saying from the start, turn the expressions into addition. When you do that, and they say here by definition of subtraction, remember the definition of subtraction is anything that makes an addition problem true. So that is why we can take minus 4x, and as you can see what they've done here is turn it into plus a negative 4x. Now you can identify what the terms are, just like they do here. 3x, negative 4x, y, and negative 2 The like terms are 3x and negative 4x. The coefficients are 3, negative 4, and 1. Notice where the 1 comes from. Remember, every time you have an unknown or a variable, there is a hidden 1 or a negative 1 in front of it, and the constant is a negative 2 because it does not have any variables with it. Okay, so an algebraic expression in its simplest form, if it has no like terms and no parentheses. When you use a distributive property to combine like terms, you are doing what is called simplifying the expression. So it's important to understand the directions, because if you don't understand what it means to simplify the expression, I've had a lot of people say, well, what's the answer? Well, there is no answer here. We are just simplifying it to make it a smaller or simpler expression. So go ahead and copy these two examples down. All right, here are some more examples. Make sure you look at the teaching tips too, because that will help identify. And notice what they're doing here. They are justifying each step of the process. Do not be surprised if I ask you to do the same thing here. So definition of subtraction, commutative property, distributive property, and then simplifying. So again, the work that you show, especially in algebra, is going to be crucial, and you need to be able to identify each step of the way. So once you're done copying these couple of examples down, go ahead and go on. So let's do a concept check. Expressions like 4 times the quantity of x minus 3, 4x minus 12, and x plus 3x minus 12 are equivalent expressions, which is in its simplest form. Again, go ahead and write down your answer, and then when you're done, go ahead and click to see what the answer is. You should have said 4x minus 12. All right, you can also use expressions when you translate verbal phrases. So here is a word problem. In words, you identify the important parts. You have some cards, your brother has 15 more. You pick a variable or an unknown to represent the cards you have, and then you have an expression that represents the card your brother has. And when you put that together, notice how you can combine the like terms. In this case, it'd be a 1x and a 1x. And you end up with 2x plus 15. So the expression 2x plus 15 represents the total number of cards that, and x is representing what you have. So it could be 10, it could be 20, but whatever the number is, your brother has 15 more than you. Okay? All right, here is some check for understanding. There's 16 problems here. Go ahead and do them. Stop the video until you have them done, and then you can go ahead and continue, and the answers will show up afterwards so you can check your answers. Okay, that should be it, and bring your work into class tomorrow. We'll do some more practice on simplifying expressions.